Matrices, Practices Part 2. Question number 5. A gift shop sells 3 types of gift baskets for different occasions. The table below shows some of the content. I have Valentine, Mother, Father, that means Valentine's Day, Mother's Day, Father's Day. And the type of things inside the gift basket have chocolates and flour. So represent the data in the above table by a 3 by 2 matrix N. So it's quite clear that N will be 3 rows, Valentine's, Mother's Day, Father's Day, and 2 columns, chocolate and flour. So this shall be the first part of the answer. Then now they tell us that part 2, chocolate costs $1.50 per bar and a stock of flour costs $2 each. Write down a 2 by 1 matrix P for the contents. So part 2, the 2 by 1 matrix will be 2 rows. In this case, we are looking at chocolate and flowers. So we shall have 2 rows to be chocolate and flowers. And our column is obviously the price. So it's $1.50. Remember to add a 1.50 because we're talking about money, and $2. Next one, compute NP and interpret the elements. So we are taking the quantity of Valentine's Day, Mother's Day, and Father's Day for chocolate and flowers, to be multiplied to the relevant prices for chocolate and flowers as well, $1.50, $2. So eventually we'll get a final matrix. This have 3 rows, so we will also have 3 rows, Valentine's Day, Mother's Day, and Father's Day, and 1 column, which is the amount of money. This is telling me it's about the cost of the content. Okay, so the total cost of each of the Valentine's Day, Mother's Day, or Father's Day basket. And we will get the answer for the following. So now let us interpret the elements in NP. So this matrix tells us that it's the total cost. It represents the total cost. In this case, it's in dollars, I think. In dollars. Okay, for each of the basket. So for the Valentine's, Mother's Day, and Father's Day gift basket respectively. So we will have the total cost. In dollars is actually optional. Okay, Valentine's, Mother's Day, and Father's Day gift basket respectively. Have you gotten the answer? Let W be the matrix 1, 1, 1. Compute W and P. So W will be 1, 1, 1. And we have our NP previously is $30, $20, 50 cents, and 15. Now when we do this multiplication, I'll get 1 times 30 plus 1 times 20.5 plus 1 times 15. So this is basically asking us for the sum. So this is talking about the total price, total money, okay, that I have spent on making the contents of all the different items in the gift basket. So let's calculate the answer, and we have $65.50. Remember to add brackets for your matrices, okay, because it's still a matrix itself. So now let us interpret this result. This will be, it represents the total cost of making the gift baskets. Okay, and this one is simpler because they have no other special components to mention. So have you gotten the answer? Let us move on to the next question. During weekdays, a restaurant serves set lunches and set dinners. Two variations of lunches and dinners are served. So now what are weekdays in this case that they have? We have Monday, Tuesday, Wednesday. Set lunch A, B, and dinner set C, set D. From these are the number of meals that were sold from each of the days. The prices of each of them are A, B, C, D, and these are the prices. Write down a matrix 3x4 matrix N that represents the set meals sold from Monday to Wednesday. So it's quite obvious that N will have 3 rows, and the 3 rows will obviously be Monday, Tuesday, Wednesday. So each of the following data we have a lot of data to consider. So this would be A, B, C, and D. Write down a matrix 4x1 matrix P to represent the prices of the set meal 4x1. So in this case, we will be talking about prices. So it will be 4 different prices, A, B, C, and D. Since it's talking about price or money, please leave your answers in 2 decimal places. So we write accordingly the answers given in the table. Okay, now we're going to use these 2 matrices to find the next part of the answer. Part 3 of the question asks us to evaluate NP. So N is the quantity, number of meals that was sold, and P is the price. So if you were to work out this solution, I will have a 3x1 column. 3 rows will be from Monday, Tuesday, and Wednesday, and the 1 column will come from the total price. So it's actually talking about the earnings that they have received from selling all the different set meals. Take some time to do the calculations, and after much calculations, I got this set of answer. Do you get something similar with me? Now, please remember that we are talking about money or price in this case. So in my answer, I actually left all the answers to corrected to 2 decimal places. Now, part 4, they ask us to explain what the numbers in NP represent. Like I mentioned, I took the quantity for A, B, C, and D and multiplied it to the prices for A, B, C, and D. That will give me the total amount of earnings. Okay, so remember, it represents the total earnings earned on, okay, the total earnings earned by selling the set meals on the 3 days. What are the 3 respective days? So Monday, Tuesday, and Wednesday. State them out. Do not just write the 3 days. So state them out explicitly on Monday, Tuesday, and Wednesday respectively. Alright, so we cover the main key terms. They want the total earnings, so that is the money, and Monday, Tuesday, and Wednesday respectively. Now they want us to calculate the total earnings for the set meals sold for the 3 days. They didn't explicitly say that we have to do it in the matrix method. So what you can do, you can just take 4122.40 plus and get the total answer. Alternatively, I can do it in a more matrix method where I can use this row matrix 1, 1, 1 and multiply it to the column 4122.40, 4592.50, and the last but not least, this amount. So when we use this row matrix here, it actually helps to sum up the total for all the different earnings. And this can be used if the question says using matrix multiplication. So therefore, the total earnings $13,168.40. Have you gotten the answer? Question number 7. Two mobile phones companies sold 2 different models of handphones in the month of June. Now we have the model Shop A, Shop B, and Model X, Model Y. It cost the manufacturers $78 and $69 to manufacture Model X and Y respectively. So down here in the table we got the quantity and now we get the price. Each Model X handphone was sold for $240, so we have the selling price as well, and $249 and $138. Write down a matrix 2 by 2 matrix Q to represent the number of mobile phones sold. So the quantity in this case, part 1, will be simple. 2 by 2 meaning Shop A, Shop B, Model X and Model Y. So we will get our answer over here. Now it's given that the cost C is actually a cost of making, so this is something like the cost. And now we have the selling price. Okay, so it's $249 and $138. Calculate Q times C and interpret the elements of QC. So let's calculate Q times C, part 2. So for QC, that will be taking the cost, Shop A, Shop B, the quantity, multiplied to the cost. Cost is Model X, Model Y, 78 and 69. That means I will get a total cost of making the phones in Shop A and Shop B. Cost in Shop A will be 7161 and the cost in Shop B will be 5871. Okay, interpret the elements of QC, so it represents the total cost of making the handphones in Shop A and B respectively. So it's just talking about the cost, so total cost, Shop A, Shop B respectively. Next one, calculate Q times S minus C. What what is S minus C? S minus C is actually taking the selling price minus away the cost price. So let's work out a little bit on S minus C first. So matrix S minus C will give me, taking the selling price 249, subtract the cost price, so 171. So what does it mean by taking selling price minus cost price? I will get the profits. Okay, so we are actually taking the quantity now. So in shop A, shop B, model X and Y. Multiplied to the profits for handphone X and Y, the profit. So what will we get? We will get a 2 by 1 matrix, which means shop A, shop B in the row, and profits in the column. And working out our answers, we will get 11997 and 9498. What does this matrix means? Interpret the elements. It represents the total profits earned in shop A and B respectively. So we will have our two rows, shop A, shop B, the total profits in the column, and respectively. Have you gotten the answer? Moving on, question 8 and question 9 can be quite brain consuming, so please take a good break before you decide to continue with question 8 and question 9. And if you are ready, we will begin. Question 8. On every weekday morning from Monday to Fridays, so I'll have 5 weekdays, a bus carries 10 adult passengers, so you have adults, and 30 children. On every weekday afternoon, oh that was morning and this is afternoon, it carries 20 adults and 10 children. So taking a look at our matrix over here, we have morning and afternoon, 10 and 30, then 20 and 10. Yeah. On a Saturday, it carries 25 adults, 15 children. That is Saturday morning. And Saturday afternoon, it carries 10 adults and 30 children. Represent the number of passengers carried on Saturday by a matrix D. Now we're going to follow a similar trend given in matrix C, which says in the morning and in the afternoon, and then the adults and the children. So Saturday morning will be 25 and adults, 15 children. Saturday afternoon will be 10 adults and 30 children. Next part, part 2, evaluate E to be 5C. What is C? C is the number of passengers on weekdays. Why do I have 5C? So that means I will have 5 weekdays, which is Monday to Friday, I think, and then 1 Saturday. And we'll be able to get our answers for morning and afternoon, adults and children, for a total of 5 weekdays and 1 Saturday. Okay, and we get the following answer. So state what does the elements of E represent. So in this case, we are talking about passengers. And to be more specific, it's not just passengers, it's adult and children passengers. Okay, so it represents total number of adults and children passengers the bus carried on 5 workdays, 8 weekdays, and 1 Saturday. Let's check if we have satisfied all the different items requirements. I need the column adult and children. I have the total number of passengers. I explained that it's actually 5 weekdays and 1 Saturday. Oh, I have not answered that it's in the morning and afternoon. So I need to add on. So represent the total number of adults and children passengers on 5 weekdays and 1 Saturday in morning and the afternoon respectively. Yeah. Then we get our answer. Have you gotten your answer? Now some students will probably ask, can we write instead of 5 weekdays and 1 Saturday, can we write from Monday to Saturday? Well, it looks logical because you have 5 weekdays and 1 Saturday. So that variation of answer is acceptable. Next part of the question. The fare for an adult is 25 cents and the fare for a child is 15 cents. Evaluate the matrix F to be C bracket 25, 15. Oh, let's take a look at what is C. C is actually the very first matrix that we begin with. The number of adults and children in the morning and afternoon on a weekday, one weekday. So now they're asking us to evaluate FC. So that will be taking this matrix and multiplying it to the cost, 25 cents, 15 cents. So this is in cents. So we should, and this is morning and afternoon. So we should get a 2 by 1 matrix where it's talking about morning and afternoon and the total amount of money in cents that we have collected. Let's try to work out the answers. And I get the following answer, 700 cents for morning and 650 cents for afternoon. And this is only for just 1 weekday, right? So part B, interpret what the elements in F represents. It represents the total fare earned on 1 weekday the total fare earned in cents earned on 1 weekday for the morning and afternoon sessions. So now let's do a quick check. I will have the columns which is talking about money earned in cents in particular, and I'm talking about the 2 rows, morning and afternoon, and I interpret that is for 1 weekday. So, and I'll need to have the word respectively. Next one, part C. Part C asks us to evaluate the matrix G is 1 over 100. 1 times F. Let's work this out part by part. I will have 1 over 100. Let me keep this scalar multiple and work out matrix multiplication 1, 1 times the matrix F first. So 1, 1 multiplied to 700 and 650, that will give me 1 over 100. And 1 times 700 plus 1 times 650. So 700 plus 650. This is actually talking about the total amount of fare that you got from one weekday. But this was originally in cents. Now I'm dividing this, multiplying it by 1 over 100. That means instead of cents, I'm changing this amount to dollars. So I'll get my answer to be 13.50. So what does this matrix represent? This matrix actually represents the total cost of fare in dollars collected in one weekday. Have you gotten your answer? Question number 9. The following table records the number of notes of denomination of $2, $5, and $10 in each of the 3 cashiers' cash register. So we have on Saturday and Sunday night as well. The information for all this denomination on a Saturday night is given as follows. So they want us to write down the matrix Q for a Sunday night. So in that case, matrix Q will be a 3 by 3 matrix where it will be Francis, Helen, and Suraidi. Okay, on $2, $5, and $10 denomination. So we'll get the following answer. Okay, so that's for Q. Now evaluate the matrix S equals to half P plus Q. What do you mean by P plus Q? P and Q add together is the sum. I add the two of them together and I divide by 2. That actually gives me the average. So when we are looking for matrix S, it's actually looking for the average of Saturday and Sunday nights money, right? Let us take a look at part 2. So to find S is half of P plus Q. So I'm going to take this 2 first. So P add to the matrix Q and then later multiply by half. So I'll have half multiplied to the matrix. Give us some time to get the answer. 18, 25, 11, 18, 22, 16, 19, 18, and 10. And now we try to get the answer. For half of this, we will get 9, 12.5, 5.5, 9, 11, 8, 19 divided by 2, $9.50, 18, and half. Okay, this should be matrix S. Describe what is represented by the elements of S. So now we know that the rows are actually coming from Francis, Helen, and Suraidi. The denominations, the average number of denomination of $2 notes, $5 notes, and $10 notes. So how are we going to write down this matrix? It represents the average number of $2 of notes of the denomination of $2, $5, and $10 for Francis, Helen, and Suraidi on Saturday and Sunday night. On Saturday and Sunday, respectively. Right, so let's check through our matrix. We have our columns, the meaning of it, the half means the average number. Okay, and we have our row columns is $2, $5, $10. The three rows, Francis, Helen, and Suraidi, and the word respectively. Alright, have you gotten the answer? Next part, given that n equals to the denominations 2, 5, and 10 of the notes, evaluate s times n. So z equals to s. Now I've written down the matrix for s already, and which is the average number of dollar notes for $2, $5, and $10. So now I have the various representing the value $2, $5, and $10, and that actually represents the money. So for Francis, Helen, and Suraidi, okay, we have to evaluate this and describe what it means by the elements. So if I were to do a multiplication, I'll get a 3 by 1 matrix. Francis, Helen, and Suraidi. Now taking the number of $2 notes, you need 9 times $2 plus 12.5 times 5 plus 5.5 times 10 actually gives us the average amount of cash value, the average amount of money that each of them have in their own cashier. So let's work out for the rest of the students, the rest of the cashiers. And I have 153 over here. And I got 114. Okay, do you get anything that's similar? Hopefully my answer is correct. So in this case, we have Sn, which is the matrix Z. Describe what is represented by the elements of Z. It represents the average, because S was originally average, cash value, because now I've multiplied them to $2, $5, and $10, right? The actual cash value, okay, collected by the cashiers. The three cashiers, who are they? Francis, Helen, and Suraidi. Okay, the average cash value collected by Francis, Helen, and Suraidi on Saturday and Sunday, respectively. Okay, so we have the average cash value, average, and Francis, Helen, and Suraidi, so respectively. So this is what we want. Alright, let's take a look at the last part 5. Given that M is 111, evaluate T such that it will be 111, and from the different caches 13550. Now notice what happens if I were to multiply this out. I will only have one row and one column, okay, for money. So this is definitely going to be the average cash value, but I'm going to add up. Take 1 times 135.5 0.5, I add a total of 1 times 153 plus 1 times 114. So this will give me actually the total average cash values, okay, collected. Now there's no longer Francis, Helen and Suraidi, so it will be just what they collected on Saturday and Sunday. So what does it represent? It represents the total average cash value collected on Saturday and Sunday. No more respectively. So there's only one answer. Have you gotten the answer? Now we have come to the end of this part of the matrices. Now hopefully you have done some good practices and do a little bit more of revision on the questions that you are not sure of. Now see you for the next chapter.